Hello and welcome to each and everyone watching this video. We, student of BTech, and our group number is 11. Our topic is Mapreduce. The team consists of Abhimanyu Negi, Nikhil Jethanandani, Sahil Kothari, Priyavinda, and myself Archit Singh. The index of this video will be explanation of Mapreduce, explanation of Hadoop, the explanation of configuration files, and at last the working of a project. So basically, what is Mapreduce? In a very simple language, Mapreduce is a programming model for writing applications that can process big data in parallel on multiple nodes. Mapreduce provides analytical capabilities for analyzing huge volumes of complex data. Big data is a collection of large datasets that cannot be processed using traditional computing techniques. It offers several benefits to help you gain valuable insights from your big data. Some of them are scalability, flexibility, and speed. MapReduce is the heart of Apache Hadoop. The term MapReduce refers to two separate and distinct tasks that Hadoop programs. The first is a map job, which takes a set of data and converts it into another set of data, where individual elements are broken down into tuples. The reduce job takes the output from a map as input and combines those data tuples into a smaller set of tuples. As the sequence of the name MapReduce implies, the reduce job is always performed after the map job. The primary motivation of MapReduce was that computationally intensive jobs distributed across large clusters of machines needed a simple way to manage them in a parallelized, scalable, and fault-tolerant way. MapReduce is the processing unit of Hadoop using which the data in Hadoop can be processed.
So now you may be wondering what Hadoop is. Hadoop presents MapReduce as an analytics engine and under the hood uses a distributed storage layer referred to as Hadoop Distributed File System. Typically, HDFS is a storage unit, while Hadoop MapReduce is a processing unit. At Google, MapReduce operations are run on a special file system called Google File System that is highly optimized for this purpose, but it is not open source. So later, Douglas Cutting and Yahoo reversed engineered the GFS and called it the Hadoop Distributed File System. Now let's talk about what makes it so important and user-friendly. First, the system is able to store and process numerous amounts of data at an extremely fast rate. A semi-structured, structured, and unstructured dataset can differ depending on how the data is structured. Second, enhances operational decision-making and batch workloads for historical analysis by supporting real-time analytics. Third, data can be stored by organizations and it can be filtered for specific analytical uses by processors as needed. A large number of nodes can be added to Hadoop as it is scalable, so organizations will be able to pick up more data. Fifth, a protection mechanism prevents applications and data processing from being harmed by hardware failures. Nodes that are down are automatically redirected to other nodes, allowing applications to run without interruption. Based on the above reasons, we can say that Hadoop is important.
We have already discussed the theory of MapReduce and Hadoop. Let us jump into the demonstration of a project. We will first discuss the configuration files, the SSH, and then the working of our project. We will talk about the configuration files. The replication in HDFS or Hadoop Distributed File System refers to a process where we store multiple copies of the data blocks across different data nodes, which will ensure fault tolerance and data availability. The replication factor that we have considered in our system is 3, as we have a master node and 2 slave nodes. Now what master node and slave nodes are? They are the two key components which are responsible for managing and storing data in a distributed manner across the Hadoop cluster. Master node is also called as name node. It is a central metadata management component. It will keep the track of the file system hierarchy and at the same time will have the metadata information such as the file names, permissions, directories, and the location of each file's data block. It will maintain the information in memory for faster access. Data node. They are also called as the slave nodes. They are responsible for storing and serving the actual data blocks of the files. Each data node will manage the storage on its local machine and store the data in the form of blocks. They will periodically report their health status and the list of blocks they are hosting to the name node or the master node. They also perform tasks such as block creation, deletion, replication, etc. So we could summarize that the master node or name node is a central metadata server. Now we could easily see that we have wrote the address of the name node and the data node in our project. These three are the IP addresses of the master node and the slave node. What is most unique about a project is the master node in this project also acts as the slave node.
Let's talk about how the different nodes in Hadoop communicate with each other. The master node should be able to communicate to all other slave nodes, and it does this with the help of SSH or secure shell. SSH is a network protocol that allows users to communicate securely over an unsecure network. It is a key-based authentication and hence does not require a password. Hadoop requires a passwordless SSH connection between the master and all the slaves and secondary machines so that it does not have to ask for authentication every time, as master and slaves require rigorous communication. Now, what you see on the screen are the SSH public keys for the master and the slave nodes. The keys start with SSH RSA, which represents the type of the key, the actual key, followed by a comment which I've underlined, which tells us about the user or the system associated with the key. These keys are generated using the command shown on the screen. On executing this command, the system generates a new RSA key pair which consists of a public key and a private key. The public key can be shared with the remote systems, allowing them to authenticate securely without a password, and the private key should be kept secure as it is used for authentication on our local system.
So now let us see the working of the Mapreduce program in Hadoop. So currently on our screen, we can see the Hadoop administrator, which gives us the name node information. So from here, we can see that we have in our system 3 live nodes. When we open it, we get 3 live nodes as master, slave 1, and slave 2. It is important to note that in the current system, we are using the master node to perform the functions of master as well as the slave. So now let us browse the file system. So currently we have an input folder inside which we have an input.txt file. Through this file, we give the input to the MapReducer program in order to perform the word count functionality. So this is the current text file that we have given for input. So now let us in the terminal run the command in order to compile the code and make sure that the word count program runs and we get the output using the MapReduce structure of Hadoop. So as we can see, currently the server is working for the MapReducer program and it has already given us the output. We can check this in the file browsing system again. So let us now go back there. So as we can see that output folder has come now. When we click on it, we can see that we have 2 files, that is success and part R000. We have an answer in this. So here we can see that we have the availability of 3 nodes, that is master, slave 1 and slave 2, which means that while this program was created or this file was created as an output of 3 nodes which were working together in order to perform the MapReducer function. So let us download this file and see the contents of the file. Okay, so we can see this is the output of our file, and actually we can compare it with the input if we want. Let's try that. Yeah, so this is our input, and for the word count, this is our output. So that's pretty much it for the working of the MapReduce program using Hadoop. Thank you.